Today's video is about grams to gram stoichiometry. So remember, stoichiometry was that very useful and very helpful aspect of chemistry that allows us to convert from moles of one thing to moles of another thing, which is very helpful in chemistry. We can predict the amounts of products, we can predict the amounts of reactants needed to produce those products, and so let's look at a real life example here. So it says, question number 1, several brands of antacid tablets use aluminum hydroxide to neutralize excess stomach acid. We have hydrochloric acid in our stomach, and sometimes a little too much of that can be uncomfortable. So this is the balanced equation given to us. We have aluminum hydroxide reacts with 3 HCl molecules to produce aluminum chloride and water. And so this is already balanced for us, and so we're going to use this balanced equation to figure out some things. So let's look at our problem here first. And so it says, what quantity of HCl in grams can a tablet with 0.0750 grams of aluminum hydroxide consume? So we'll start off identifying our known quantity, and that's going to be 0.750. That's our known quantity. And then we need to identify our unknown quantity. There's our known. And our unknown, what quantity in HCl in grams? So we're looking for grams of HCl. So we're going to use both of those pieces of information here. And so we're going to make a picket fence, make a real long one here. And we're going to put our known over here, 0.750 grams of AlOH3. And we're going to put our unknown way out here, grams of HCl. Okay, so this is essentially telling us where we're going to start on our mole road and where we're going to end on our mole road. And remember, so we're starting at grams. So grams is right down here on our mole road. There's grams. And we're ending also at grams. So we're ending right here on the mole road. And remember, because we have two different substances, we have aluminum hydroxide as our starting point and we have HCl as our ending point, we need to go up the mole road from grams to moles. And then remember, we put into our mole road our kind of roundabout there, and we said we were going to put our unknown over our known from our balanced equation. Those were going to be our coefficients. And so our first conversion factor as we travel from grams up to moles, as the mole road says, is going to be 1 mole over the atomic mass, or molar mass. So that's going to be grams of aluminum hydroxide, our starting point. And so what I have to do is grab our calculator or periodic table and punch in our molar mass of aluminum hydroxide, 1 aluminum plus 3 oxygens plus 3 hydrogens, and I'll do that right now. Okay, when I calculated the molar mass of aluminum hydroxide, I get 78.0. So we're going to call it 78. Okay, now that took us from grams up to moles, and remember, we need to go around the unknown over the known. So here's what I do. I go over here to HCl, which HCl right here is my unknown, and I'm going to just rewrite HCl right here. And then I'm going to take my known, which remember my known was aluminum hydroxide, which is right here, and I'm going to write aluminum hydroxide on the bottom. Now we remember the values for the unknown over the known, or our mole ratio, are coming from our balanced equation. So I just look up to the balanced equation, and I have 3 moles of HCl. So I'm going to put 3 moles of HCl there, and I have 1 mole of aluminum hydroxide there. And so I'm almost done. I've just to check, we've gone around the unknown over the known. And now we need to go back down to grams, and so it's atomic mass over 1 mole. So I'm going to put 1 mole on the bottom. And atomic mass, it reminded us, we put out here at the end, we put our grams of HCl, which is what we're looking for. So that reminds us that we're going to need to calculate the atomic mass of HCl. So I'm going to go ahead and calculate the atomic mass of HCl, which is 1H is 1.01 and 1Cl is 35.45, and I add those two together. I'm just going to erase this so I can just fit everything in there, and we'll go 36.46 grams of HCl. Again, I added one hydrogen to one chlorine. Now, on this type of problem, we're going to want to multiply everything across the top. 0.750 times 1 times 3 times 35.46. I put parentheses around that, and we're going to divide it by the bottom. Now, because I have 1 and 1 on the bottom, I don't need to really do anything but divide it by 78. If I had a 2 as a mole ratio for the aluminum hydroxide, I would need to put that in parentheses too. So let's go ahead and do that real quick and get an answer. Okay, and so the answer that I got when I punched this through my calculator is I get 1.051730769. So way too many sig figs, so we're going to round it off. We have 3 sig figs as our known, so we're going to round it off to 1.05. Now I'm going to go through and double check that everything is set up right by canceling units. Grams with aluminum hydroxide cancels with grams of aluminum hydroxide. Moles of aluminum hydroxide cancels with moles. Moles of HCl cancels with moles of HCl. So I'm left with an answer of grams of HCl, and that's our answer here. Okay, let's do one more problem here. Okay, so here's our problem. We're going to have 2.75 grams of aluminum hydroxide reacting with excess HCl. What mass of water will be made? So let's kind of analyze this thing first here. So our known value here is 2.75 grams of aluminum hydroxide. There's our known. It says excess HCl. Remember, we've talked about it in a previous video. When we talk about excess, it means we have enough to go around, and we don't have to worry about it. We can just ignore it for now. And it says what mass of water will be made. So mass is telling us we're going to grams of water, and that's our unknown. Okay, so we're once again going to make a picket fence. We'll make it pretty long, and we're going to go 2.75 grams of aluminum hydroxide, and we're going to put grams of water way out here at the end, and I'm going to use my mole road to kind of guide me along here. So again, we're starting with grams. We're going to go up the road to moles. We're going to go around the unknown over the known. Again, we get those numbers from our balanced equation, the coefficients of the balanced equation for those. And then we're going to go back down the road to grams and end up at grams of water. So it's going to be a 3-step problem. So we're going to put, to start off with, remember grams going up to moles. We're going to put 1 mole over the atomic mass, 1 mole of aluminum hydroxide over grams of aluminum hydroxide. And we need to calculate the atomic mass. We did that in a previous problem, and so we know it's 78 grams of aluminum hydroxide. Again, we added 1 aluminum plus 3 oxygens plus 3 hydrogens together. Now we're at the mole, down here on the mole road. We've gone 1 step up to the mole. We're going to go around that unknown over the known from the balanced equation. So what I like to do is I like to take my unknown, which is the water, and I just rewrite it right here, H2O. I just slid it over. Then I take my known, and remember my known is my aluminum hydroxide, and I'm going to go ahead and write aluminum hydroxide down here in the bottom. Now the numbers come from the balanced equation here, so we're going to look up to the balanced equation. There's water right there, so we're going to put 3 moles. And there's aluminum hydroxide there, and we're going to put 1 mole. We just use those coefficients, remember, and if there's nothing in front of aluminum hydroxide, we use a coefficient of 1. Last thing we need to do now is we're on our mole road is we're going to go back down the road to grams, and it's going to be atomic mass over 1 mole. 1 mole goes on the bottom, and we just have to calculate atomic mass of water. 2 hydrogens is 2.02 plus 16 for oxygen, so we have 18.02 grams listed right there. And again, multiply everything across the top and divide by 78. And the coefficients were 1 on the bottom again, so we're okay. So let's see what we get here in our calculator. Okay, so my calculator gave me 1.90596 and a bunch of other numbers. And so we want to round off to our known. We have 3 sig figs, and so we're going to go 1.91, and then let's go ahead and cancel some units. Grams of aluminum hydroxide, grams of aluminum hydroxide cancels. Moles and moles cancels. Moles of water cancels. So we're left with an answer in grams of H2O. And so if we start with 2.75 grams, we're going to make 1.91 grams of water. And that is how we do grams to gram stoichiometry.